Hello everyone, in this video we're going to talk about putting quadratic equations in vertex form. Here's our example for today. This equation is in standard form. Standard form of a quadratic has an x squared and then an x and then a constant in that order. And there's a y equals or a 0 equals out front. And they want this equation in vertex form. So remember, vertex form looks like this: y equals 1 over 4p x minus h squared plus k. If you're given a parentheses squared with a plus or minus sign inside and an x inside, that's a good sign that your equation's probably in vertex form. So we need our equation to look like this, and we're going to use completing the square to make that happen. So completing the square, we always have to check to see if the number in front of x squared is 1. If it's not, we need to divide everything. So if this were a 2, we would have to divide everything by 2. But this is a 1, so we're good. The next step of completing the square is to get the constant away from everything else. So we're going to do minus 31 to both sides. We have y minus 31 equals x squared plus 8x. So now this is what we're completing the square on. Let's find our superhero number. To do that, we do 1/2 b squared. So we do 1/2 of this number, which is 18, squared. Half of 18 is 9. 9 squared is 81. 81 is the superhero that's going to come in and save the day. We're going to add 81 to both sides. Over here, we can actually combine some like terms. Negative 31 plus 81 is y plus 50 equals this one. There's no like terms, so we just tack it on to the end here. All right, the whole reason we did that is so that we can factor this perfect square trinomial. This wasn't perfect before, but now it is. This is a perfect square trinomial. If I asked you, can you give me two numbers that multiply to 81 that add up to 18? The answer is yes, I can, and they're the same number. It's 9 and 9, right? So x plus 9, x plus 9. Those two numbers multiply to 81 and add up to 18. And the reason why that's so exciting is I don't have to write it twice. I can just write it once with a squared out front. And look at that, our equation almost looks like what we need it to look like. We need a parentheses squared. Now this one has a plus k. This one doesn't have that plus k until we move the 50 over there. We're done with the 50 being away from us. So let's move it back over here. Y equals parentheses x plus 9 squared minus 50. So this is in vertex form. I know that we don't have a fraction out front. That's okay. Not all of them need a fraction out front. Now that this is in vertex form, the whole reason vertex form exists is without doing a whole lot of work, I could just look at this equation and tell you what is the vertex of this parabola. If I were to graph this quadratic equation, it would make a U-shaped graph called a parabola that has a turning point, has a vertex. Where is the vertex? It's this number and this number. This number here should be minus, and it's not. So that means our x-coordinate of our vertex is negative 9. Our y-coordinate, this one says it should be plus, and it's not. So our y-coordinate is negative 50. So a good way of remembering this is when dealing with vertex form, the number inside here is the opposite of what we see. So that's a plus 9, but we're going to write a minus 9. And the number out here is exactly what we need. No changes needed. So that means the minus 50 is the y-coordinate. So the whole reason we did all that was so we could find the vertex easily. The vertex of this equation is negative 9, negative 50. And we did this whole question with the process of completing the square. So that's all for today. Thanks for watching. Have a good day.